Alright, so on this last day for Unit 4, we are going to look at something called L'Hopital's rule, and it looks like La Hospital. You guys will really like this mathematician because it just made limits that much easier, and you'll see here in just a bit. So L'Hopital's rule, and we'll also look at linearization today. And this is for approximating functions. And it's using the equation of the tangent line. Okay, so let's go ahead and start. It's been a while since we've done limits. And if you saw a limit like this, chances are you approached it by first doing direct substitution. That means we put the x, we replaced with 3's, and we get this 0 over 0 indeterminate form. So what we are learning today are two indeterminate forms, which are 0 over 0 and infinity over infinity. Okay, the very first thing that I need to say is please do not say that this is equal to 0 over 0, because if you do, it throws the whole proof off and you can't use the proof. You're not saying that it's equal to, you're just referring it to one of these indeterminate forms. Okay? So let's say we don't know L'Hopital's yet. Old school, you would have done this. You would have factored the bottom as well. You would have noticed a cancellation, a removable discontinuity, and then you would have approached 3 from the right. So since you canceled this, it would go away. And algebraically, you're seeing, if I approach 3 infinitely from the right, the numbers that we were playing around with when we first looked at that were like the nearest 1,000. So if I plug the nearest 1,000th right here, the top is going to be very close to 6. Now think of a number line. Here's 3, and here's 0. And if I'm picking 3.001, it's right there. This number I'm going to put right here. What does it make the denominator?
Very small.
A very small number, positive or negative?
Positive.
So it's a positive small. So what's 6 divided by a very positive small? Infinity. A positive infinity. So the answer for this should have been infinity. Okay? So now, some of us, we'll get to that in just a bit. L'Hopital's rule is going to simplify this big time. Okay? You'll see in just a bit of why and how it works. So that's the old way. That's showing all the work. Let's go ahead and now go over to the second one. The second one, if I were to ask you, how do we algebraically manipulate that, what would you do?
Factor.
Factor how?
So it would make that kind of like a difference of cubes thing.
Okay.
And then, so like what I did is I like took out the e term first and factored like normal.
So you wrote e.
I just took out the e and thought about it without the e first, and I said x cubed minus 1, and I factored that into x minus 1 times x squared plus x plus 1, and then made all of the x's e to the x or e to the 2x.
Okay, so there, like you could hear, it's pretty involved. There's a lot to do with this problem. Okay, so what I want to do right now is let's learn L'Hopital's rule, because the idea is to learn L'Hopital's rule today, not to go back and relearn all the simplifications. No worries. So if we plug in 0 for x, what does the top equal? 0. What does the bottom equal? 0. So please do not put that this is equal to 0 over 0, or you will get that wrong, okay? That's not what we're saying. We're just referring to, it is the indeterminate form. This is exactly the way I want you to put it in your test. The indeterminate indeterminate form of 0 over 0. Because remember, there's two of them. Okay? So this is how we do L'Hopital's rule. Just like you say, because f prime is positive, or because the velocity and acceleration have the same signs, you need justification. So you're going to say per, or using L'Hopital's rule, we're going to show 0 over 0. Okay? And the way we show 0 over 0 is we're going to say, it basically looks like this. The limit of f of x over g of x as x is approaching a, when we cannot solve it this way, what we do is we rewrite it to a form that we might be able to solve it by taking the derivative, the derivative of the top independently from the derivative of the bottom. Let me undo this real quick. And then we just plug in our c value, or that a value that we're looking at. Okay, let's go for this piece here. So far what I have highlighted in orange or boxed in orange, this is what I want you to write on the test. And then over here you're going to say, we're going to analyze these limits individually. You would say the limit as x approaches 0 of e to the 3x minus 1 is equal to what? 0. You would then go and say the limit as x approaches 0 of 2x is equal to what? 0. So again, please don't ever write that it's equal to 0 over 0. It's implied that you just proved, or you just set this up. You've referred to the indeterminate form, so this is the work that you will show. And the L'Hopital's rule says now, all you have to do is derive them. Don't think of it as quotient rule. It's not low d high minus high d low over low low, because it's a fraction. Just what's the derivative of the top? So the derivative of the top you see is what? Go ahead.
3.
Yep. The carbon copy times the natural log of the base times the derivative of the power, which is that. You see what I'm saying? So this is going to be our new one that we're analyzing to 0. What's the other derivative going to be? 2. So you'll say that the limit as x approaches 0 is equal to what? 2 for this one, and what for this? 3. So guess what our answer is? 3/2. Because the way I want you to write it is the limit as x approaches 0 is 3e to the 3x over 2 is equal to that. Again, what I'm highlighting in orange is ultimately how I want you to write this work. I just showed you the intermittent pieces so you can see what's going on. You with me? So all of this, quickly we'll go to the answer of 3/2. Raise your hand if you got 3/2 for that one. Nice. Okay. So if we were to go back just real quick to this one, which we got infinity, and I took 3 and I plugged it in, and I got this 0 over 0, and I took the derivative. Okay, so I showed all this work, but I went straight to the limit as x approaches 3 from the right of 2x over 2x minus 6. You with me? What do we always do first before we plug in the limit? What do we always do? We always simplify before we plug in the limit, right? So what could I factor out? A 2. So, and it will cancel, right? So it'll be x minus 3, and it looks like that. You with me? So now, if I approach 3 from the right, I'm doing the same thing. It's going to be, on the top, it's going to be like 3.001, and on the bottom, it's going to be a very, very small number, a positive small. And you see how you still will get positive infinity. Okay? But it's, again, you're going to, everything in orange is what you would write out for each of the steps. So you would put like the limit of x approaching 3 from the right for the top, see what it equals, which in this case would be 0, so on and so forth.
But this
So-
one, when you, like,
So this one, you don't necessarily have to do the positive and negative smalls. It gives you clean numbers off the bat. So here's the thing. It'll either be 0, it'll be undefined, otherwise does not exist, right? Because undefined are functions, limit does not exist. So to be 0 does not exist, a positive or a negative infinity, or a quantitative number like 3/2. Okay? Let's do the last one. Okay, so the last one, we're going to use L'Hopital's rule. If you need to take a picture of this, let me pause the video. I really want you... Alright, so Braden's question just now was saying, if this is still 3, why isn't this 0 over 0 per se? Okay, so if I plugged in 3, and not something from the right of 3, I'd get 3 over 0 technically. Do you agree? Which should be does not exist. But the answer is does not exist. It's infinity. So remember how I told you infinity is a way that something doesn't exist? So it's an idea and also a number per se. Here's what I'll say. L'Hopital's rule you can still use, but the reason why you have to do something a little bit different on this one is that it's not a general limit. It's a one-sided limit that you have to gravitate just from the right. So you have to do a little bit more if it's a one-sided limit. Cool? Alright. So let's go now to number 3. Okay, so number 3 we're going to develop, and if you have the picture that's good, we're going to develop as far as using L'Hopital's rule. Now again, please be honest with me of what you have written down as the answer. We'll look at it here in just a bit. But if I plug this in, what would I get? Infinity over infinity or 0 over 0? 0 over 0. So put the indeterminate form, or 0 over 0, indeterminate form. And this is basically going to set us up for our work that we're going to show by hand. Okay? So the work is going to be the limit as x approaches 1 of that, which is equal to, anyone?
0!
Oh my gosh, 0. I'm recording. And then the limit as x approaches 1 of the denominator, which is the square root of x squared minus 1 is equal to what? 0. So this just proves my indeterminate form. And from here, I'm going to go quickly to build the new limit. The L'Hopital's rule limit as far as taking the derivative of the top independently from the bottom. Now notice, the top, let's do in red. I'll just do it in blue. We'll go 10x. What's the derivative of the bottom?
1/2
1/2 times what?
x squared minus 1 to the negative 1/2 times x, or times 2x.
Times 2x. So all you did was a chain rule for the bottom one. And if I simplify this bottom piece, technically it's 2x over 2 square roots of x squared minus 1. It's still all under 10x. Go with me? What do we always do before plugging in this 1? We have to simplify. Because if I plug in a 1 right now, I'm going to get 10 over 2 over 0. Which technically should be does not exist. But I have to simplify before I plug in the limit. So 10x divided by this is the same as multiplying by what? The reciprocal. So we have 10x multiplied by the reciprocal will give me all of this. We know we could cancel the 2's and the x's. So in a sense, all I have is this left over. You with me? So then if I now have the limit as x approaches 1, and I plug it in here, what would I get?
Still 0.
I would get 0. So over here, the other way I got does not exist. But if I simplify fully and then plug in, I would get 0. So the answer for this is 0. We would start here. We would work down, and yes, this right here would be all the way down here, and this would be our last step.
Can't you solve it without using L'Hopital's rule?
So here's the thing. If you can solve it without using L'Hopital's rule, go for it. If it's a multiple choice question. If it's a free response and they say using L'Hopital's rule, you must show all of this quote-unquote annoying, meaningless, why am I doing this kind of proof stuff. Almost like we did in geometry with certain proofs. Okay? It feels like that. It looks like that. But in a lot of respect, it's easier.
Because for that one, I just factored out a 5 and then squared
Yep.
square root at the top.
For sure. And then you just reduce it.
Yeah.
But again, using L'Hopital's rule, they want us to actually go through the steps. But what Christian said, if this is the multiple choice, guys, I don't expect you to do L'Hopital's rule. That's a waste of time.
How would you solve number 2 without L'Hopital's rule?
Very carefully. For the sake of time, I'm going to keep going, okay? All right, so the answers that you should have gotten were infinity, 3/2, and 0. So now you have these three. I will still give you 6 minutes, but now I expect you to use L'Hopital's rule, all the writing and notation for these 3 practice problems before we move on to linearization. All right, so a couple things that I saw when you guys were working. So when you first do direct substitution, some of you see a 0 over a 0. But please, please do not do that. They will not give you the parts and the credit and the points that you need if it's a free response question, which most likely will occur. You don't want to set it equal to 0 over 0 because you're already throwing off the formal way of doing the proof for L'Hopital's rule. Okay? So off to the side, what I would do is, yes, direct substitution will give me a 0 over 0. And to me, I'm just referencing that it's the indeterminate form that allows me to use L'Hopital's rule. We will go ahead and go through and list all the pieces. Okay? The first one that we will do is the limit as x approaches 5 of the top. We're verifying that, yep, it's 0. The limit as x approaches 5, you got to write all these pieces. Of the bottom, sure enough, is 0. So from that, using L'Hopital's rule, we're going to go ahead and come over here to the quotient of the derivatives. And we're going to have 2 over 2x minus 2. We're good? And then we're going to try and plug in the 5 again. So right now, if I plug in the 5, I know I get 2/8, otherwise 1/4. So here's what you ask yourself. If you get something right here that is something other than a 0 over a 0, then you're done. That's your answer. Okay? Let's say you got 0 over 0 again, which may happen. Or if you get infinity over infinity again, guess what you have to do all over again? From this step, you would treat it like a new problem and just do this all over again as far as showing that the top is equal to 0, the bottom is equal to 0. Then, therefore, take the derivative again, and you're going to still do that until you don't get 0 over 0 or infinity over infinity anymore. It will either be 0, does not exist, positive or negative infinity, or a quantitative answer. Okay? And that's pretty much it. So for this one, the answer is 1/4. Yes?
What if you like keep deriving and doing it, and then you always get 0 over 0?
So here's the thing. If it's repetitive and you cannot get 0, you're going to have to use other forms and other strategies per se. And I'll show you one of those here in just a bit. Okay? That was a really good question because sometimes it won't work.
So So is it going to specify on the test like you have to use L'Hopital's rule? Because for this one you can just factor it and it's easy.
Yeah, it'll say using
It'll say
L'Hopital's rule.
Oh, I was gonna ask like whether there's like in the test like would there be like a multiple choice question where
Yep,
like
there'll be multiple choice that you could use. Their limit multiple choices, and if you could quickly use L'Hopital's rule, go for it. But here's the thing: on those multiple choice questions, they know you've just. A lot of times, people in the past, I used to teach this at the end of the year, so it was fresh in people's minds. So they see a limit with fractions, and they immediately go to L'Hopital's rule, and it could be one that did not even require L'Hopital's rule. So they would get the wrong answer because they should have never done L'Hopital's rule. Remember, you have to first verify whether it's one of these two indeterminate forms before you use L'Hopital's rule. Don't get L'Hopital crazy. You know what I mean? Don't go to all limits and be like, life is awesome now, and you're just going to L'Hopital everything, because then you can mess everything up, okay? All right, so the answer is 1/4. All right? So let's go ahead and circle this real quick, because I want you to bonus point this up. Mentioning this is 10 points, okay? Mentioning the using the L'Hopital's rule is 10 points. Each of these is going to be 10 points. The rewrite with the derivatives is going to be 10 points. And then last but not least, the answer itself is 10 points. So 1, 2, 3, 4, 5, 6. Keep track of those, okay? So that's 60 for that one. All right. Let's go to the second one. So again, L'Hopital crazy. People would go to this and be like, ooh, cosine of x, that's beautiful, over 1. Now I could just go ahead and plug in pi over 2. And they'll say cosine of pi over 2 is 0. And they would be wrong. They're going to say, yay, the answer is 0. But they should have never used L'Hopital's rule. Because the first thing to do is to always do direct substitution. And you tell me, what's the sign of pi over 2? 1. So this is really 1 over pi over 2, which is my answer is 2 over pi. So that's 2 over pi units off. You with me? Okay, so just seeing this, it's just 10 points. That's all it is. Okay, no L'Hopital's rule. We should probably do minus if you did all L'Hopital. No, I'm joking.
Yep.
All right, so looking at this next one, plugging in 0, I get a 0 over 0 form. Okay, and yes, back in the good old days when things were much easier, I just said more easier. Anyway, and I'm recording. So looking at this, if I were to multiply by something called the conjugate, remember this? I know it's been a while, but this is what we would do back in the old day. This is old school work. You don't distribute the denominator and it would give you the answer. But that's inefficient. Okay? So now we're going to say the indeterminate form not equal to, but just mention of it. And then we will have to say using L'Hopital's rule. So here's what I'll say. Let me take that back. It won't say, hey, use L'Hopital's rule. It will give you a limit that has a quotient of some kind. To where when you see it and you plug in direct substitution, you're like, ooh, 0 over 0. Or infinity over infinity. You have to say using L'Hopital's rule. So again, let me fix that on what I said earlier. It will not tell you when to use it. You have to know when to use it. But you already know from this.
So even if you like know how to do it without using L'Hopital's rule, if it gives you one of the
Yep, you still have to. Yeah. So using L'Hopital's rule, we're going to quickly verify that sure enough, the limit as x approaches 0 for the top and the bottom, and you just write the equations out as needed. The square root of 25 minus x squared minus 5 is equal to 0, and sure enough, x is equal to 0. Now I know I've run out of room, but down here, you would write the derivative of the top and the bottom, which is 1. That 5 zeroes out, so this is going to be 1/2 of all this to the negative 1/2 times what? Times the derivative of the inside, which is negative 2x. We always simplify before we plugged in. The 1 isn't even needed anymore, right? So you could say this is a negative x over 25 minus x squared, which is square rooted. And this is the limit as x is approaching 0. You with me? So if I plugged in 0 right now, what's the numerator equal? 0. What is the denominator equal? 5. Is 0 divided by 5 a number?
Yes.
0. So this one, let's give it points. We'll say 10, 20, 30, 40, 50, and 60. Okay, so now linearization is different. Linearization is the equation of the tangent line, which you know as y minus y1 equals m times x minus x1. Yeah, sometimes mathematicians like to get a little fancy, throw all these letters at you. X of 1 is a. Y of 1 is f of a. And the slope is f prime at a. Everything else remains the same. Same thing. Then, if I get y alone and I add f of a to both sides, this is what I have. This will get into something that you'll see with integrals here next semester. So this is the linearization form to approximate values. Okay? If I were to go ahead with the calculator real quick, can you put the square root of 103 and put control enter? Okay, we get 10.1489, and if I click on it, if I click on 10.1489, it gives you a lot more decimals. So real quick, just to show you on the video, the square root of 103 controlled enter gives you this, but if I go up, whoops, if I go up and I click on it, I can actually get the value, which is a lot more decimals as far as that you should display. So right now, this is the exact value, and I'm going to show you of how you can get this as an approximate value with the equation of the tangent line. Okay, so let me show you with that real quick. Let me go back to the notes, and I'm going to show you with the steps. So first of all, f of x is going to be defined as far as the function that we're working with. What's the function anyone that we're working with? Square root of x. Okay. Furthermore, we are looking for f prime. So f prime is 1/2 the square root of x on the bottom. Our known value is 100. So if I'm looking at 100, it's because I know what the square root of 100 is. Okay? I don't know what the square root of 103 is, but I know what the square root of 100 is. And that's almost like my center. Okay? I can go over here to this equation and I can put f of 100, considering this, is what? Like 10. And here, if my a value is 100, this is my known. What would my slope be at 100? 120. So now when I go ahead and put this into the equation, it's going to be x minus 100. What I've just built for myself, listen, is almost like a linear function, well it is, that has a, look at this, y equals mx plus b, where b is my y-intercept at 10. I'm shooting out from this y-intercept at a slope of up 1 over 20, and I'm going to move, when I put this 103 in here, I'm going to move 3 units to the right. You see what I'm doing? So if I move 3 units to the right at this slope, this y value that it projects into the future will be my approximate. It's really cool stuff. You know the meaning and what this is used for going forward. It's really cool stuff to project results. Okay? It will show you what it wants to be, which in this case, please for the calculator with me real quick, what I want you to do is use this equation because this is the approximated value of that output, and I want you to put 103 where x is at. Okay? So put 103 where x is at and tell me what you get as a decimal.
What do you mean put 103 where x is at?
So on this entire equation, you can write this out, guys. Just put this on the home screen. I want you to put 10 plus 1 over 20 times what? 3? What do you get as far as a decimal point, guys?
10.5.
10.15? Okay, so 10.15 is our, so we'll put 0 since it's 3 decimals in calc. This is our approximated answer. And if you look at the calculator, it is really close to what the exact answer would be. Okay, so what I want you to do for bonus points now is I want you to look at number 3. I want you to do number 3, and with all the steps that we just did for bonus points and groups, I want you to get the answer for that. So resuming the video, we're doing number 3. Notice how I established my f of x. I also established my derivative, x to the power of 2/3. Okay. My a value, basically my center, is what? 1,000. And now I will build it by saying y is equal to f of a, which is f of 1,000. So f of 1,000, which is going to be put in right here, will give me what? 10. And I'm going to add the slope of f prime at a. So here we go. The cubed root of that is 10. Squared is 100. So it's going to be 1 over what? 1 over 300. And then it will be x minus 1,000. And you see here, you don't always have to go upward. You could go downward. Okay? So if I do this and I'm going to plug in my x value, which is your unknown, right here, it's going to be a negative 2. We'll multiply with this 1 over 300. Add it to 10 to 3 decimals, Rovic. What do I get?
It's 9.993.
9.993, right? And if you were to put, and it's like repeating, isn't it? Something like that, 9.993 repeating. This is an approximate answer because it came from an approximate equation of a tangent line. But if I put this strictly into my calculator, I kid you not, it is really, really close to exactly that. Again, if you need to find more decimals on the calculator, whenever you get an answer, just like this one, just click up, press enter, and it'll show more decimals. Otherwise, you can press home 52, change this to all float, make it your default, so that when you go back and you solve it, it will give you your answer. Well, that one's ran out of time. But anyway, you get the gist.
Was that for group 1?